Hello and welcome to one of a series of videos on AQA A-level Chemistry, Paper 3 or Component 74053. This video is focusing on the 2019 paper, and I'm going to be talking through each of the multiple choice questions, providing an explanation as to how to get to the answer. The likelihood is if you're watching this video you're just looking for one of the specific explanations to one of the questions, and so I'll add in timestamps so you can navigate to that question. Starting off then with question number 6. Which amount of sodium hydroxide would react with exactly 7.5 grams of a diprotic acid, H2A? And it tells you the MR there. So step 1, you're given the mass and the MR of the acid. So firstly work out the moles of the acid, mass over MR. 7.5 grams divided by the MR of 150, which gives us 0.05 moles. Now it's a diprotic acid and it's reacting with sodium hydroxide, so it's going to make a salt plus water, and because the salt is a 2- charge, or it's a diprotic acid, you're going to need 2 sodiums there, which means the fact that it's a diprotic acid means the molar ratio of acid to sodium hydroxide is 1 to 2. So if we know the moles of acid, which we worked out up here, we can work out the moles of NaOH, moles of acid times by 2. So the moles of NaOH is 0.10 moles. So which of these answers will give us 0.10 moles? So you need to go through, you're given the volume and the concentration in each case. So remember, moles can be worked out by doing concentration times volume, and if it's centimetres cubed, don't forget to divide each volume by 1000 when you're doing this calculation. So in A we have 0.0025 moles, B we have 0.05 moles, C we have 0.1 moles, and D we have 0.2 moles. So from the calculation below you can see that the correct moles of sodium hydroxide should be 0.1, because it's a 1 to 2 ratio of the acid to the sodium hydroxide. Answer C is correct. Question number 7. Lead nitrate and potassium iodide react according to the equation. So again, this is a chemical calculations question. Which amount in moles of lead iodide is formed? So you're given the volume and concentration of lead nitrate and potassium iodide. So let's work out the moles of each solution. So concentration times by volume, concentration is 0.1, volume is 25 over 1000. So that gives us moles of 0.0025. You also have the moles of potassium iodide. It's the same concentration and same volume, so you've got 0.0025 moles of that as well. I'll just write those numbers in at the top. So because you've got the same amount of moles of each, but you've got a 1 to 2 ratio of the lead nitrate to the potassium iodide, you need to work out which one is the limiting reagent, which one is going to be completely used up, and which one is going to be left over after the reaction. It's the moles of the limiting reagent which will determine how much lead iodide is made. So in this case, because it's a 1 to 2 ratio, the potassium iodide is the limiting reagent. 0.0025 moles of potassium iodide would completely react, and only 0.00125 moles, or half the number of moles, of lead nitrate will react. So the lead nitrate is in excess there. So we use the moles of Ki to determine the moles of PbI2. So what's the moles of lead iodide? It's a 2-to-1 ratio. So the moles of lead iodide is the moles of potassium iodide divided by 2. So that's 0.00125 moles of lead iodide formed, or 1.25 times 10 to the minus 2. Times 10 to the minus 3. Question number 8. Nitrogen oxide is produced from ammonia and air, as shown in these equations. So what's the enthalpy change for the following reaction? So you've got 4NH3, 7O2 to make 4NO2 and 6 waters. So we're given a couple of equations here. The ammonia will react with oxygen to produce NO. The NO will react with oxygen to produce NO2. So this isn't quite a combustion cycle, it's about working out how these equations match up with the equation that you're trying to work out. So equation 1, you've got ammonia producing NO. Ammonia is in the equation and it produces NO as it reacts with oxygen. So if we were constructing a Hess cycle, that arrow on the left is going to be pointing down. Again, NH3 forms NO. NO is at the bottom of our cycle. In equation 2, you've got NO making NO2. Well, NO2 is in our balanced equation on the right hand side, and it's being made from NO. So that right hand arrow is going to be pointing upwards. So 4NH3 goes to 4NO. So that value there, equation 1, gives us a value of minus 909 kilojoules per mole. 2NO to 2NO2 in the second equation is a value of minus 115 kilojoules per mole. But in our equation we've got 4NO to 4NO2. So that equation must be multiplied by 2. So to find the overall enthalpy change, we go with the arrow this way, so we add minus 909, and then we go with the arrow this way, so we're going to add minus 115 times 2, which gives us our final enthalpy change, or overall enthalpy change, of minus 1139 kilojoules per mole, or answer D. Question number 9. Which change leads to a higher concentration of sulfur trioxide in the equilibrium mixture? So if we were to have a higher concentration of oxygen, if you were to increase the amount of oxygen, you're going to increase how much that reacts with SO2. That's going to force equilibrium to the right. That would make more SO3. So A is correct. Let's just go through B, C and D and eliminate those answers in case you put one of those. So if you were to have a higher temperature, equilibrium is going to shift in the endothermic direction. The forward reaction is exothermic. So a higher temperature is going to shift it in the endothermic direction and make less sulfur trioxide. Statement C, if you have a lower pressure is going to shift it to the side with more moles of gas. You've got 2 moles on the right, you've got 3 moles on the left. So that would make less SO3 as equilibrium shifts to the left. Hopefully you're aware, use of catalyst has no effect on the position of equilibrium, so that would not affect the yield. Question number 10. Results of an investigation of the reaction between P and Q are shown in this table. So you're given a rate equation and asked to calculate the initial concentration of Q in experiment 2. There are 2 ways that you can do this. The first way, you can work out the effect of P, what's happening to the overall rate, and therefore calculate Q in that way. I find that way is a little bit tricky with my students, so a better way is to, or an easier way, is to find the value of K from experiment 1. So K can be worked out by rearranging the rate equation. So K is rate over P times Q squared. And again, we'll use the values from experiment 1 to find the value of K. So K is 0.4 is the rate, divided by the concentration of P times by the concentration of Q squared. So that gives us a value of K of exactly 8. Now that we know the value of K, in experiment 2 we can work out the value of Q. So rearrange the rate equation to make Q the subject. So Q, or Q squared, is going to be rate divided by K times P. And because that's Q squared, we would then need to square root both sides. So now that we have all of our values, we just need to work out what Q is. So Q, using the value of K that you just worked out, we've got the rate, which is 0.8, divided by 8 times the concentration of P in the second experiment, which is 0.6. Square root the whole answer, and that gives you a value of Q being 0.408, or answer C. Question number 11. We have the same equilibrium expression as before. You've got sulfur dioxide reacting with oxygen to make 2 SO3. So I'm just going to rewrite this equation here because we'll need it in a second. In an experiment, you've got 2 moles of sulfur dioxide mixed with 2 moles of oxygen. It doesn't tell you how much sulfur trioxide you have to start with, so we'll assume that is 0 to begin with. That's our initial moles. The total amount of the 3 gases at equilibrium is 3.4 moles. So what's the mole fraction of sulfur trioxide? If you're given the initial moles in an equilibrium reaction, you've probably done a table like this, sometimes referred to as an ICE table. Initial moles, change in moles, and equilibrium moles. So we don't know what the change in moles are, we don't know what the equilibrium moles are at this stage, but we do know that the total moles is 3.4. So if we had the moles of sulfur dioxide at equilibrium, the moles of oxygen at equilibrium, and the moles of SO3, the total moles again is 3.4. So the change in moles is going to be, let's call it X. So if X moles of oxygen reacts, then you're going to have 2 minus X moles of oxygen at equilibrium. If X moles of oxygen is reacted, then 2X moles of sulfur dioxide is reacting. So at equilibrium, you would have 2 minus 2X moles of SO2. And because our SO3 is a product, if you've got 2X moles of SO2 being reacted, you would make 2X moles of SO3. So you started with no moles, the moles of SO3 goes up by 2X. That gives us 2X moles at equilibrium. So if the total moles is 3.4, then the total moles of sulfur dioxide, oxygen and sulfur trioxide are added together, that will give us 3.4. We're being asked to work out the mole fraction of sulfur trioxide. So expand the brackets and calculate the value of X. So by expanding the brackets, that's going to give us 4 minus X is 3.4. So minus X equals minus 0.6, or X equals 0.60. So what's the moles of sulfur trioxide at equilibrium? Well, it's 2 times X, or 2 times 0.6. So the moles of sulfur trioxide is 1.20 moles. Therefore, Therefore, what is the mole fraction? Mole fraction is the number of moles of sulfur trioxide divided by the total moles. So plug that last little equation into your calculator. That will give you a mole fraction of 0.353. Or answer B. Question 12, another equilibrium question here. So nitrogen and hydrogen react together in the Haber process to make ammonia. Which change increases the equilibrium yield of ammonia, but has no effect on the value of the equilibrium constant? So temperature is the only factor that affects the equilibrium constant. So any changes in temperature will not only affect the yield, but it will also affect the value of Kp, or Kc if we were looking at that. So that means we can ignore question or statement C there. Any other change in factors or conditions will not affect the value of Kp. As we mentioned before, adding a catalyst will have no effect on the yield. It increases the rate of the forward and backwards reactions equally, but no effect on yield. What would happen if we decrease the total pressure? We'll come back to statement B in a second. If you were to decrease the total pressure, equilibrium is going to shift to the side with more moles of gas. It's going to shift to the side with more moles of gas, which means we're going to make more N2 and 3H2 because we've got 4 moles on the left. So that would lower the yield of NH3. So that means statement B must be correct. If you were to increase the partial pressure of nitrogen, so by causing the pressure of nitrogen to increase, it's going to force the particles to be closer together. It's going to force the nitrogen to react with the hydrogen. It's going to shift to the side with fewer moles of gas, just like it would if you were to increase the overall pressure. So increasing the partial pressure of nitrogen forces it to the side with fewer moles of gas, or to make more NH3. Question 13. What is the EMF of the cell? You've got iron and copper, and you're given the two balanced equations there. So if you're given the cell, which we are in this case, to work out the electrode potential, you do right hand side, the cathode, minus left hand side. So what's on the right hand side? The right hand side is copper. So you've got 0.34, take away the left hand side, which is Fe2+, so minus 0.44, to give us the overall E value of plus 0.78 volts. There are multiple ways of working out these calculations, but right take away left if you're given the cell diagram, I find is the easiest. Question number 14. Which atom has the greatest first ionisation energy? So ionisation energy is affected, or the value of ionisation energy will change according to shielding. The less shielding, the stronger the attraction between the outer electron and the nucleus. The number of protons, and kind of linked to shielding is the distance of the outer electrons to the nucleus. So looking at these different atoms, which one has the most protons, the least shielding, and the smallest distance of the outer electrons to the nucleus? That will cause it to have the highest first ionisation energy. So hydrogen has no shielding, but it has one proton. Helium again is in period 1, it's only got one shell or energy level, so it's got no shielding, but helium has 2 protons, so helium would have a higher first ionisation energy than hydrogen. Lithium and neon are both in period 2. So their outer electrons are further from the nucleus and there is a bit of shielding involved. So helium has the greatest first ionisation energy of all elements, in fact. So answer B, or statement B, is correct. Question number 15. What is the correct observation when barium metal is added to an excess of water? So barium, just like the group 1 and group 2 metals, when they're added to water, will form a hydroxide. Group 1 is the alkali metals, group 2 is the alkaline earth metals. So you're going to get barium hydroxide, and you also get hydrogen gas. Anytime you add group 1 or group 2 to metals to water, you get the hydroxide and hydrogen gas. Now barium hydroxide, you have to think about your knowledge of the solubilities of the group 2 hydroxides. Is barium hydroxide soluble or insoluble? Well, it is in fact soluble, because it gets more soluble as you go down the group when we're thinking about the group 2 hydroxides. So you'll get a colourless solution of barium hydroxide and you'll get hydrogen gas produced. So you're going to get a colourless solution of barium hydroxide and effervescence of hydrogen gas. So on to question 16. An aqueous solution of a salt gives a white precipitate when mixed with aqueous silver nitrate and when mixed with dilute sulfuric acid. So what could be the formula of the salt? So when it reacts with aqueous silver nitrate, it is the silver ion that's going to form the precipitate. So silver compound is a white precipitate out of these. So we're looking at the anions. It's not silver sulfate. It could be one of the chlorides. So you should be aware that silver chloride is a white solid or a white precipitate. When it's mixed with dilute sulfuric acid, it's going to also form a white precipitate. So we know what the negative ion is, we know what the anion is, so this is to work out the cation. Which cation will react with the sulfate ions in sulfuric acid to form a white precipitate? So it could be barium, ammonium, potassium or strontium. And you should be aware that when barium ions are reacted with sulfate, you get a white precipitate of barium sulfate, because it's an insoluble group 2 sulfate. So therefore our compound has barium ions and chloride ions. Answer A is correct. Question 17. Which statement is not correct about the trends in properties of the hydrogen halides from HCl to HI? So I'm just writing the atoms, I'm drawing them bigger, because as you go down from HCl to HBr to HI, the size of the molecules are going to increase. So would the boiling points increase or decrease down the group? Well, they're all polar, they're all going to have dipole-dipole forces, but because the molecules are getting bigger, you're going to get stronger van der Waals forces between molecules, so statement A is incorrect. The boiling points would increase because you're going to have stronger van der Waals forces between molecules. So A is not correct. Let's just go through answers B to D to eliminate those, make sure they are all correct. So does the bond dissociation energy decrease? Well, as you go down the group from HCl to HBr to HI, the atoms are getting larger, so there's a larger distance between the nuclei and the shared pair of electrons, and therefore it's going to be easier to break those bonds. So the bond dissociation enthalpy does indeed decrease down the group. Does the polarity of the hydrogen halide bond decrease? Well, polarity is based on electronegativity difference. Out of chlorine, bromine and iodine, chlorine has the highest electronegativity, which means HCl is the most polar bond, followed by HBr, followed by HI. are they more easily oxidized in aqueous solutions? So the hydrogen halides will have an oxidation state for halides of -1. So when they're oxidized, they are losing electrons to become the diatomic element. So which one is going to lose the electrons most easily? Well, chloride has the least amount of shielding, so that's not oxidized easily. Iodide is a large ion, it very easily loses electrons, so that is easily oxidized. So going down from HCl to HBr to Hi, they are indeed oxidized more easily in aqueous solutions. Question number 18. What's observed when concentrated hydrochloric acid is added to an aqueous solution of copper sulfate until no further change occurs? So if you have an aqueous solution of copper sulfate, that means the copper ions are floating around in lots of water, the predominant complex that exists is going to be your hexa aqua copper 2. When you add concentrated hydrochloric acid, you're adding lots of chloride ligands. And so you're going to get a ligand substitution reaction happening here. The chloride will swap in for the waters and you get a tetrahedral complex of copper chloride and 6 water. So what are we going to observe? Well, hexa aqua copper 2 is a blue solution. Copper chloride is a lime green solution. So you're going to get a colour change happening. You don't get any gas evolved here, you're just going to get 6 waters as a byproduct. Again, no gas is evolved. You're not going to get a precipitate, you're going to get another complex, because the complex has an overall charge that is aqueous, so you're not getting a precipitate. The solution does indeed change colour, as I've mentioned, but there is no precipitate forming. So answer D is correct. Question number 19. What is the most suitable reagent for detecting the presence of carbonate ions in the presence of sulfate ions? So if you've got a mixture containing both carbonate and sulfate, how can you detect the presence of carbonate ions? So adding sodium hydroxide, there would be no overall reaction. Similarly, if you add sodium chloride, there would be no overall reaction. Adding barium chloride, well, you should be aware that barium ions will react with carbonate ions to form a white precipitate. So you get a white precipitate of barium carbonate formed. However, barium ions would also react with sulfate ions to form a white precipitate of barium sulfate, as we saw in the previous question. So barium chloride can detect carbonate ions, but not in the presence of sulfate, because both of them will react. Adding an acid, however, the acid contains hydrogen ions, that's going to react with your carbonate ions to produce carbon dioxide gas and water. Carbon dioxide gas will effervesce. So that's the best way for detecting carbonate ions, adding sulfuric acid or any other acid. Question number 20. Methylbenzene is going to react with concentrated nitric acid, excuse the terrible drawing there, and concentrated sulfuric acid, which is a catalyst, and you're going to get nitromethylbenzene and water as your byproduct. Nitric acid, sulfuric acid makes NO2+ when they react together. NO2+ is an electrophile. The NO2 is added on to the benzene ring and a hydrogen atom is removed. So you've got an electrophile that is substituting in for a hydrogen on the benzene ring. That's an electrophilic substitution reaction. Question 21. Possible synthesis of a compound found in jasmine flower oil is shown. So it's a multi-stage step synthesis which mechanism is not used in this synthesis. So I'll go through each one, each step in this reaction sequence and just identify what's happening. So you're going from an alkane to a haloalkane here. That's going to happen by free radical substitution. So free radical substitution occurs as the halogen joins on. You need UV light for that to occur. Your chlorine is then being swapped or substituted for a hydroxide ion. So you need sodium or potassium hydroxide in an aqueous solution. That one is nucleophilic substitution. And then finally you're going from an alkyl group to a C double bond O single bond O. You're forming an ester. So that's esterification. And when you form an ester, that occurs via nucleophilic addition elimination. So free radical substitution occurs in step 1, then nucleophilic substitution, then nucleophilic addition elimination. There is no electrophilic substitution. There is nothing being added to the benzene ring. So this mechanism doesn't occur. Question number 22. Which compound is formed when 1-phenyl ethanol reacts with acidified potassium dichromate? So let's start by drawing out 1-phenyl ethanol. So if you have your OH group on carbon 1, OH takes priority, so it doesn't need a number. And the phenyl group is also on carbon 1. So you're going to have your C6H5 there. So 1-phenyl ethanol reacts with acidified potassium dichromate. It's going to be oxidized. What's it going to form? So your benzene ring remains unchanged. You get your C double bond O on the first carbon and your CH3 remains unchanged. So you're going to form phenyl ethanone here. Plus water as your byproduct. So which one matches the phenyl ethanone? It is this compound here. If you said B or D, then you drew 2-phenyl ethanol instead. But 1-phenyl ethanol is a secondary alcohol. It's going to form a ketone, which we can see here. Question 23. 3 reagents are added separately to 4 organic compounds. Which row shows the correct observations? So you're adding sodium hydrogen carbonate. That will cause effervescence with a carboxylic acid. You've got acidified potassium dichromate. That's an oxidizing agent. That's going to react with primary or secondary alcohols. It will also react with aldehydes. And Tollens reagent is a weaker oxidizing agent, so it can't oxidize alcohols, but it will oxidize aldehydes. So, which one shows the correct reaction? Propanoic acid would effervesce. It wouldn't react with acidified potassium dichromate because it can't be oxidized, and it wouldn't react with Tollens reagents because again it can't be oxidized there. So D is incorrect. Propanone would have no visible change with sodium hydrogen carbonate. It would have no visible change with acidified potassium dichromate because it's a ketone, and it would have no visible change with Tollens reagent. So C is incorrect. Let's go through B. So B is an aldehyde. It wouldn't react with sodium hydrogen carbonate. There would be no visible change. It can be oxidized by dichromate, as orange solution would turn green, and it would react with Tollens reagent to produce a silver mirror. And let's just eliminate A. So propan-1-ol would not effervesce with sodium hydrogen carbonate. It would go from orange to green, and there would be no visible change with Tollens reagent. So A is incorrect. B is correct. Question 24. Which compound is formed by the acid hydrolysis of phenyl methyl ethanoate? So we have an ester here. Let's break it down. The ethanoate is the carboxylic acid derivative. And your phenyl methyl, that's going to be from phenyl methanol. So you're going to have your CH2, and then that's going to be bonded to your C6H5 or your benzene ring. Acid hydrolysis is going to cause the ester to break down into the carboxylic acid, so ethanoic acid, and phenyl methanol, so C6H5 CH2OH. So that means answer A is the alcohol formed by the acid hydrolysis here. Just a side note, if it was base hydrolysis instead of acid hydrolysis, you would get the same alcohol, but you would get the carboxylic acid salt instead. Question 25. A student is required to dry a liquid sample of pentanoic acid. So drying is the removal of water. So a suitable drying agent is one which is insoluble and which is going to react or bond with the water. So going through the examples here, calcium oxide is not suitable because, as you learnt from the group 2 topic, group 2 oxides will react with water to form group 2 hydroxides. Calcium hydroxide is partially soluble, so that's not a suitable drying agent. You're not going to be able to remove water that way. Calcium sulfate is a useful drying agent. So calcium sulfate is one that's used, and hydrous calcium sulfate will react with water molecules to form hydrated calcium sulfate solid. So B is correct. Potassium hydroxide and potassium carbonate are both soluble ionic compounds, so they're not useful drying agents because they're just going to dissolve in the water that's present. So calcium sulfate is an example of a drying agent that's worth learning. Question 26. The reaction between propanoyl chloride and benzene is an example of acylation. So when acylation occurs with benzene, you have your acyl chloride, in this case it's propanoyl chloride, which reacts with aluminium chloride to produce the electrophile, so CH3, CH2, CO with a positive charge on the carbon, and AlCl4-. The CH3, CH2CO, the acylium ion, is going to bond to your benzene ring via electrophilic substitution. So which of these arrows is correct? Well, the arrow A is not showing the movement of a pair of electrons, so arrow A is incorrect. Similarly, arrow B, there's no electrons on the aluminium, so the aluminium is not going to have electrons moving from the aluminium to the chlorine. There's no electrons there. So A and B do not show the movement of electrons. Arrow C, once you've got the acylium ion, the thing that I've drawn down here, the positive charge is going to be attracted to the benzene ring. The ring of delocalized electrons will be attracted towards the positive carbon. So arrow C is correct. You get an intermediate benzene structure formed, but it is the electrons that are holding the hydrogen in that will go into the ring, the positive intermediate. Not this arrow. This arrow is incorrect because that would cause the positive ion to break off again. So arrow D is incorrect. It should be from the CH bond instead. So answer C is correct. Question 27. Methylamine, CH3NH2, will react with bromoethane, so that's C2H5Br, via nucleophilic substitution. You can have further substitution, so what's going to happen here is your methylamine acts as a nucleophile, lone pair is going to attack the delta positive carbon and the bromine will break off. Methylamine is a primary amine. You will form a secondary amine with the formula C2H5 NHCH3, ethyl methylamine. That will react further with our bromoethane. So another carbon chain is going to add on to the nitrogen. So you're going to have two ethyl groups bonded to the nitrogen. Another hydrogen comes off. So you'll have diethyl methylamine. And then you still have a lone pair on the nitrogen. So that's going to react further with the bromoethane to get another ethyl group joined. The nitrogen has now formed 4 bonds. So the nitrogen is positive. So that would be triethyl methyl ammonium bromide. So A is formed as the primary amine turns into a secondary amine. B is formed as the secondary amine turns into a tertiary amine. And C is formed as the tertiary amine forms a quaternary ammonium salt. D would not form because there's one too many methyl groups and not enough ethyl groups. So D is the correct answer. Question 28 is about polymers, so this question requires an understanding or knowledge of the structure of certain polymers. So Kevlar is a polyamide. Polyamides will have amide links. Polythene, made up of polyethene, so you're going to have your repeat unit look something like this. PVC, you should be aware, is polyvinyl chloride or polychloroethene, so your repeat units for PVC. It's an addition polymer, just like polythene, but you're going to have a chlorine bonded instead of a hydrogen. And finally, terylene or PET is an example of a polyester. You have your C double bondo, single bondo as part of the repeat unit. So that's your ester link. Now ester links have no OH bonds, just C double bond O and single bond O. So you're just going to have dipole-dipole forces between polyester chains. So no hydrogen bonds. PVC, you've got a CCl bond, so that's polar. You're going to have dipole-dipole forces between chains in PVC, so no hydrogen bonds. Polythene is non-polar, so you're going to have van der Waals forces between molecules or between chains. Kevlar is our only polyamide. Polyamides have an NH group, so a delta positive hydrogen, which would be attracted to the lone pair on the oxygen or the nitrogen of adjoining chains. So Kevlar, our polyamide, will have hydrogen bonds between chains. That joins on quite nicely to question 29, so which shows the part of a peptide link in a protein. So a peptide link is the same as an amide link, but it exists between amino acids. So a peptide link has your C double bond O, NH. It's not A. A is an ester link. It wouldn't be B, because when you have your CONH, so that bit's correct, but the NH would be joined to the remaining part of an amino acid, so you wouldn't have that. You would have your CH group and your R group there. This one in C wouldn't occur, again that's an ester group. C double bond O, single bond O. Sorry, it's not an ester group, that is an acid anhydride group. So C double bond O, NH is present in amides, it's an amide link, or between proteins, it's a peptide link. So D is correct there. Question number 30. Base of DNA linked together by hydrogen bonding. Which row shows the number of hydrogen bonds between the pair of bases? Use the data booklet to help you answer this question. Now, many students doing A-level chemistry will also do A-level biology, so you may not need to use the data booklet. You can use the data booklet to work this out, however. But adenine is going to form 2 hydrogen bonds with thymine, and cytosine is going to form 3 hydrogen bonds with guanine. So which one does that match? Adenine does not pair with guanine, cytosine does not pair with thymine, guanine pairs with cytosine via 3 hydrogen bonds. Adenine does pair with thymine, but it forms 2 hydrogen bonds. So C is correct there. Question 31. Which is not responsible for the conduction of electricity? So molten sodium chloride, molten ionic compounds, the ions are free to move, so will conduct electricity. You should be aware there are delocalized electrons between layers of carbon atoms in graphite. Graphite is capable of conducting electricity. It's often used as electrodes, for example. The electrons in a metal, the bonding electrons, also known as the delocalized electrons. Delocalized electrons are attracted to the positive ions, so that's why they're known as the bonding electrons. They are free to move and carry a current. Metals can conduct electricity. However, the lone pair of electrons on water molecules is not able to flow, so therefore that one is not responsible for the conduction of electricity. Question 32. You've got industrial ethanol now produced by direct hydration of ethene. This has replaced the fermentation method. So why are we going to use mainly hydration to produce ethanol? What are the advantages of hydration? You have the idea that it is a much faster process. It is going to require less separation. So when you use fermentation, you get a mixture of substances produced. You have to separate out the ethanol from the glucose that produces it. And you get a higher yield of ethanol as well. So fermentation, I believe, only produces a 15% yield or thereabouts. So which is a likely reason for the change? It does indeed produce pure ethanol. That's that only product in the reaction. The direct hydration route does not employ milder conditions. You need a very high temperature, very high pressure, and a phosphoric acid catalyst, so it's not milder conditions. I've just mentioned it does use a catalyst, so C is incorrect. And it is a much quicker reaction than fermentation. Fermentation takes days, the hydration reaction will take seconds, so A is correct here. Which alkene will react with hydrogen bromide to give 2-bromo-3-methyl butane as our major product? So 2-bromo-3-methyl butane as our major product. Just draw sticks where the hydrogens are going to go. So if it's our major product, the bromide is going to join on to our carbocation, so let's work backwards. So the hydrogen will join first, the bromide will join second, second step of the mechanism. So the bromide is going to join onto this carbocation here. Methyl groups there. So where would the hydrogen be joining from in the first step of the mechanism? Now to make this carbocation as the major product, the hydrogen would not join on the third carbon because it would join onto the second carbon because that would be a more stable carbocation. So the hydrogen will in fact join here in the first step. So because it's the major product, the hydrogen joins onto the carbon with the most hydrogens on it already to produce a more stable carbocation, which I've drawn here, and it would not join onto the third carbon where the methyl group is, because that would not produce a more stable carbocation. So if the hydrogen joins on the first carbon, that means our double bond is between carbon 1 and 2. So if the double bond is in between carbon 1 and 2, that means we're going to have this as our alkene with our methyl group on carbon 3 and another methyl group or two CH3s together. So which alkene has this formula here? So just going through each of those answers, it looks like it's going to be compound D. So working backwards, you've got CH2, then you've got a double bond CH, then you've got another CH with two methyl groups attached. So compound D is the correct alkene that would form 2-bromo 3-methylbutane as the major product. Question 34. Which compound can be purified by forming a hot aqueous solution that recrystallizes on cooling? So the type of compounds that are recrystallized are your organic solids. So which one is going to be recrystallized here? So cyclohexene, should be aware, is a liquid. Organic liquid will not be recrystallized. Ethanoic acid is also a liquid. That would not be recrystallized. Phenylamine, again you should be aware, is a liquid as well. That will not be recrystallized. Benzoic acid, C6H5COOH, is indeed an organic solid. So that would form a hot aqueous solution, soluble when hot but insoluble when cold, can be recrystallized. And finally, question 35. Use the data booklet because you've got a diagram of aspartic acid there. What's the aspartic acid species present in an aqueous solution at pH 14? And if you've been through the other paper 3s, you'll see that this question is actually a repeat from, I believe it was 2022 and in 2018 off the top of my head. So if you've got a high pH, that means you have an alkaline environment. If there's an alkaline environment, then there is an absence of hydrogen ions. So your COOH in an alkaline environment or a high pH will become COO-. And in fact, aspartic acid has two COOH groups, so both of those will become COO-. If it's alkaline, so amino acids can sometimes exist as NH3+ or NH2, the amine group. If it's a high pH, there's an absence of hydrogen ions, so all the hydrogen ions are removed by the hydroxide. So therefore you're going to have NH2 present and your COO- is present. So which one has two COO- and one NH2? Well, it's answer D. So that brings me to the end of the video for the Paper 3 2019 multiple choice questions. Hopefully that's clarified any questions that you had, but if you're still unsure and you'd like further clarification, please do drop me a comment and I'll try my best to get back to you. Otherwise, best of luck with your exams and I hope they go well.